Hello, in this video I'm going to be going over scientific notation. In chemistry, scientific notation is used a lot. Usually it's used for very small numbers. However, in other fields of science, such as astronomy, it's used for very large numbers. So what happens when we have very small numbers, very large numbers, is we have all of these zeros, and it's easy to get dizzy and miscount them. So scientific notation was developed to remedy that, basically. Alright, we've got 315. I want to convert this into scientific notation. In order to do that, I need to have a whole number that's between, or it's greater than 1, less than 10. So, whole number greater than 1 and less than 10. Oh. And then I multiply it by 10 a certain number of times. So I'm going to multiply it by 10 to a certain exponent. I'm just going to call it n. It could be a negative number. It could be a positive number. If the exponent is positive, that means I'm moving the decimal. I'm moving it over to the right. Positive exponent. Decimal moving to the right. If I have a negative exponent, which is this n guy, then what I'm doing is I'm moving the decimal to the left. And essentially I'm making a very small number. So if I have 10 to the negative number, my number is going to be less than 1. If I have 10 to a positive number, my number is going to be greater than 1. So an example, 315. I need to put that into scientific notation. So the decimal is found after the last digit, after the 5. We'll zoom up on that guy. And I need to move this decimal between these numbers so that I have a number that's greater than 1 and less than 10. Alright, so we've got 1, 2, that gives me 3.15. 3.15, that's between 1 and 10, times 10 to however many times I move that decimal over. I moved it 1, 2 spots over. I'm going to call it 10 to the second. Now I need to make sure that I have my exponent correct. Is it a positive 2 or a minus 2? Well, it's a negative exponent if I move the decimal to the left, and it's a positive exponent if I move my decimal to the right. So in order to do that, to make sure, you look at your whole number, and in order to make 3.15 equal to 315, I have to move my decimal 1, 2 spots to the right. So if I'm moving it to the right, it's a positive exponent. Basically, if it's a number greater than 1, it's a positive exponent. If it's a number less than 1, negative exponent. Alright, doing 25.2. So for that one, I move my decimal 1 spot over. That gives me 2.52 times 10 to a power. That's definitely between 1 and 10. And I moved my decimal only once, and 25, that's greater than 1. So it's a positive exponent. Alright, well, why don't we do something like number 10? I'm going to move my decimal 1, 2, 3, 4 spots, so it's between a 7 and a 2. That gets me 7.21 times 10 to a 1, 2, 3, 4th power. And this number is definitely less than 1, so it's going to be a negative exponent. And really that's all there is to converting a regular number or an ordinary number into scientific notation. Well, what happens if you want to convert scientific notation into an ordinary number? So it's kind of the same deal. We got 2.12 times 10 to the second. 10 to the second means you're moving a decimal 2 spots so that you're making the number greater than 1. So we move the decimal to the right. 1, 2. So this number is 212. Alright, let's do another one. 2.17 times 10 to the negative 3. It's a negative exponent, so that means we're making the number less than 1, or the number is less than 1. And we have to move the decimal to the left. So I'm moving it to the left 1, 2, 3 spots, a 0, 0. So it's 0.00217 is my ordinary number. Why don't we try another negative one? So that's 9.56. I'm going to rewrite it. 9.76 times 10 to the negative 5th. I'm moving my decimal 1, 2, 3, 4, 5 steps. So that's 1, 2, 3, 4 zeros there. My actual number is going to be 0.123400976. And that's how you convert from scientific notation into ordinary numbers.